Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIBS Home School. This is Muhammad Emdadul, Assistant Teacher of Mathematics, National Daily English Version School, Ch-8. Dear students, today I am going to conduct a math class of class 8. Our today's topic is Chapter 8, Basic Discussion and Theorem 2-3. I'll discuss in today's class, and after the class theorem is given. It means theorem 1 is given from chapter 8 for your homework, and this is your homework for the vacation of Eid al-Fitr. Okay dear students, so you will follow the class and you will do your HW properly. Okay dear students, let us see at first what is our basic discussion of chapter 8. Now see, quadrilateral and its general properties. Quadrilateral and its general properties. Types of quadrilateral, theorem 2, theorem 3. Dear students, when I will complete today's class, you will be able to learn these topics. For this, I have written these are our learning objectives. So now at first we have to know what is quadrilateral. Dear students, in previous class, in class 4, 5, 6, 7, you have learned what is quadrilateral. Though you have learned, I have written here again the definition of quadrilateral. A figure bounded by 4 line segments is called a quadrilateral. It means in the figure, if you see A, B, C, D is a figure. This figure is bounded by 4 line segments AB, BC, CD and AD. For this figure is known as a quadrilateral, and I have written here in the above figure ABCD is a quadrilateral. Okay, now I'll discuss about the general properties of quadrilateral. Dear students, you have learned different properties of quadrilateral in many classes. In class 5, in class 6, you have learned. Though you have learned, I will discuss again to recall the properties of quadrilateral. Okay dear students, so see here, I have written here general properties of quadrilateral. I have written has 4 vertices. If you see here, A is a point, B is a point, C is a point, D is a point. These are 4 points. These 4 points of the quadrilateral are known as 4 vertices. Has 4 sides and 4 angles. A quadrilateral has 4 sides, AB, BC, CD and AD. These 4 sides are the 4 sides of a quadrilateral and 4 angles. So at point A we will get an angle, angle A, angle B at point B, angle C at point C, angle D at point D. So quadrilateral has 4 sides and 4 angles. Now sum of 4 angles is 360 degrees. It means that the measurement of the sum of 4 angles of the quadrilateral is 360 degree or 4 right angles Okay, now next property I have written here has 2 diagonals. It means that any quadrilateral has 2 diagonals. Here the diagonal is AC and another diagonal is BD. Diagonal means if we join any 2 opposite vertices by a line segment, that line segment is known as diagonal. So if we join A and C, we will get the diagonal AC, and if we join B and D, we will get the diagonal BD. So we will get only 2 diagonals for any quadrilateral. Okay dear students, I have discussed the general properties of quadrilateral. So our first topic is done, and second topic, types of quadrilateral. Here types of quadrilaterals I have written here. First I have written parallelogram. These are special types of quadrilateral I will discuss here. First one is parallelogram. What is parallelogram? A parallelogram is a quadrilateral with opposite sides parallel. It means this side and this side are opposite, so these two will be parallel. This and this one, these 2 sides are opposite, so these 2 sides also will be parallel. So we can say the definition of parallelogram in another way, that is we can say the definition is a quadrilateral having 2 pair of opposite parallel sides is known as parallelogram. The region bounded by a parallelogram is known as a parallel is known as parallelogram. Okay, now rectangle. Now next one is rectangle. A rectangle is a parallelogram with a right angle. It means if we consider this is a parallelogram, its one angle is right angle. Its one angle is right angle. If one angle is right angle, automatically all the angles of the parallelogram will be right angle, and that parallelogram is called the rectangle. Okay, so we can say a rectangle is a parallelogram with a right angle. The region bounded by a rectangle is rectangular region, is a rectangular region. Okay, now next is rhombus. Next one is rhombus. Dear students, if you see, this is similar figure of a parallelogram, and there is a difference, little difference here. Here consecutive sides are equal. Consecutive sides are equal. Sorry, adjacent sides are equal here. Adjacent sides are equal. A rhombus is a parallelogram with equal adjacent sides. That is, the opposite sides of a parallel or rhombus are parallel, and the length of four sides are equal. The region bounded by a rhombus is also called rhombus. Okay, dear students, now see, as this is a parallelogram, so opposite sides must be parallel, and as adjacent sides are equal, so we can say these four sides are mutually equal. Four sides are mutually equal. The angles may be right angle or not. May be right angle or not. For any angle, this parallelogram is known as rhombus. Okay, now square. A square is a rectangle with equal adjacent sides. That is, a square is a parallelogram with all sides equal and all right angles. The area bounded by a square is called a square. It means that if we consider a rectangle whose adjacent sides are equal, it means these sides are adjacent sides, these are equal. So these are adjacent, so these are also equal, and these are adjacent, so these are also equal. It means that all the four sides are mutually equal and all the angles must be right angle. All the angles must be right angle of a square. Okay, dear students, now I will go to the next one, that is trapezium. A trapezium is a quadrilateral with a pair of parallel sides. Here, if we see, here are two pair of sides. This is one pair, this is another pair. This one pair is parallel. It means between the two pairs, one pair will be parallel. If one pair is parallel and another pair is not parallel, then this quadrilateral is known as trapezium, as only one pair is parallel. The region bounded by a trapezium is also called a trapezium. Okay, now next one, kite. This is the last special type of quadrilateral today I will discuss. Today I am discussing here. A kite is a quadrilateral with exactly two distinct consecutive pair of sides of equal lengths. It means that here, if you see, these two sides are consecutive adjacent sides, and these two adjacent sides or consecutive sides are equal. And if you notice, this pair is also equal. Length of these two pairs are equal. It means that we can say exactly two distinct consecutive pairs of sides of equal lengths. So this type of shape is known as kite. Okay, dear students, now I'll discuss theorem 2 and theorem 3. I'll show you how can you prove theorem 2 and theorem 3. Dear students, what is theorem in this chapter? Theorem means, here if you see the note I have given, I have written a note here. If you notice this, I have written here, different types of quadrilaterals have some common properties. These properties are proved as theorem. It means that we have discussed here 6 types of quadrilateral. These are special types of quadrilateral, and every quadrilateral or every type has some special characteristics, and that characteristics are known as theorem. So among these characteristics, just I will prove two theorem, theorem 2 and theorem 3. At first I will prove theorem 2. So dear students, at first you have to know what is theorem 2. Theorem 2 I am writing here, theorem 2. Theorem 2 statement is given here. Here theorem 2 statement is written here. The opposite sides and angles of a parallelogram are equal. It means that if we consider any parallelogram, the opposite sides and angles of the parallelogram will be equal. So let us see. At first I will draw the figure of a parallelogram. Suppose here ABCD is a parallelogram. A, B, C, D is a parallelogram. And we need to prove that opposite sides of the parallelogram is equal. We can say AB, opposite side of AB is CD. So AB and CD will be equal, and opposite side of BC is AD, so BC and AD will be also equal. We need to prove this, and we need to prove that opposite angles are also equal. So we can say we need to prove angle A is equal to opposite angle of A is angle C. It means angle A is equal to angle C, and opposite angle of B is angle D. So we have to prove angle B is equal to angle D. Okay dear students, so we need to prove this. How can we prove? I'll write the proof here. So at first I will write particular enunciation. Particular enunciation I will write in short PE. Particular enunciation I am writing in short PE. Here particular enunciation will be, let A, B, C, D, let A, B, C, D be a quadrilateral, be a parallelogram, not quadrilateral, that is parallelogram. A, B, C, D is a parallelogram, and AC and BD AC and BD be two diagonals, be two diagonals. It is required to prove that, it is required to prove that first one, we need to show that opposite sides are equal. It means we need to show AB equal to CD and BC equal to AD. So we can write here. At first we need to show AB equal to CD and BC equal to AD. This means opposite sides are equal, and in part 2 we have to show that opposite angles are also equal. So we can say angle BAC is equal to, BAC means angle A is equal to angle C means BCD, and we need to show angle ABC means angle B is equal to angle ADC means angle D. We need to prove this. For this proof, construction is not needed here. So directly I will go to the part proof. How can I prove? Now see the step 1. I will write the step here, and I will write the justification in third bracket, and you will try to understand from the figure. Here if you see AV and CD, AV and CD are parallel. AB parallel CD. AC is the transversal. AC is the transversal. So we can write angle BAC is equal to angle ACD. What is the reason? As alternate angles are equal, as alternate angles, as these are alternate angles are equal. So this is the justification. Okay, now step 2. In step 2, we can say BC parallel to AD, and AC is the transversal. BC parallel AD and AC is the transversal. BC parallel AD and AC is the transversal. So you can say as BC and AD are parallel, so these two angles are also alternate angles. So we can say angle BCA is equal to angle CAD. Same reason, as alternate angles are equal. So this is the justification. Okay, now step 3. We can compare now triangle ABC and triangle ADC. In triangle ABC and triangle ADC, we can say angle BAC is equal to angle ACD. That is from step 1. Angle BCA is equal to angle CAD. That is from step 2. And if we see the figure, angle, first one BAC means this angle is equal to this angle ACD, and angle, another one is BCA means this angle, and another one angle is this angle, means CAD. So adjacent side of these two angles is AC. In this triangle also adjacent side of this two angle is AC. So AC equal to AC is the common side. AC equal to AC, common side. So justification is common side. So we can say these two triangles are congruent according to the theorem of angle side angle theorem of congruency. We can say therefore triangle ABC is congruent to triangle ADC. From this congruency will get from angle side angle theorem of congruency, angle side angle theorem of congruency, that you have learned in class 7. It means when two angles and their adjacent side will be also of a triangle is equal to the two angles and adjacent side of these angles of another triangle will be equal, then the two triangles are said to be congruent. So triangle ABC and triangle ADC are congruent. As these two triangles are congruent, so we can say AB equal to CD and BC equal to AD. So we can say, therefore, we can say AB equal to CD and BC equal to AD, and we can write here, we can use comma here, and we can take two angles, that is angle ABC equal to angle ADC. Angle ABC is equal to angle ADC. Now see here, look at the proof here. We need to prove AB equal to CD, BC equal to AD. We have done AB equal to CD and BC equal to AD. Now angle ABC equal to angle ADC. Angle ABC equal to angle ADC. So just we need to prove now angle BAC equal to angle BCD. How can we prove? Similarly, if we consider the diagonal BD, we will get the two congruent triangles ABD and BCD. ABD and BCD. So step 4, similarly, it can be proved that triangle ABD is congruent to triangle BCD. From these two triangles, we can say, therefore, this angle now BCD is equal to angle BAD. So we can say BAD is equal to BCD. Angle BAD is equal to angle BCD. So all the proof of all the portion here done. So proof is done here. Proof of theorem 2. Okay, dear students. Now I will prove theorem 3. I hope you have understood the proof of theorem 2. Now I will prove theorem 3. What is theorem 3? Theorem 3 is the diagonals of a parallelogram bisect each other. The diagonals of a parallelogram bisect each other. Dear students, for this at first we need to draw a parallelogram and then we can prove. So look at the board. I am drawing a parallelogram here. Suppose ABCD is a parallelogram and two diagonals are AC and BD intersect each other at O. As we need to prove the diagonals bisect each other, so we need to prove here AO is equal to CO and BO is equal to DO. We need to prove this. Okay, dear students. So let us see how can we write. First one is we can write particular enunciation. In short, I am writing PE. Particular enunciation. Particular enunciation should be, suppose AC and BD be two diagonals of quadrilateral ABCD intersect each other at O. Suppose, or let, you can write in your language. Suppose the two diagonals AB, diagonals AC and BD of quadrilateral or parallelogram ABCD intersect each other at O. Intersect each other at O. As the diagonals intersect each other at O, so we can write it is required to prove that AO equal to CO, AO is equal to CO, and BO is equal to DO. We need to prove this. Okay, dear students, for the proof, extra construction is not needed here, so we can write directly the proof here. Dear students, to prove this, you can consider any two triangles, triangle AOB or triangle COD. If you consider any two, in that case you can prove. Or you can triangle AOD and BOC. I'll take triangle AOB and COD. As I will take the triangle AOB and COD, at first I will consider AB parallel to CD, AC is the transversal, and then I will consider AB parallel CD, BD is the transversal. So we can say step 1 as, or we can write AB parallel CD and AC is the transversal. AC is the transversal. AC is the transversal. So we can write here angle, as AB and CD are parallel, AC is the transversal, so these two angles are alternate angles. So we can write angle BAC is equal to angle ACD. Angle BAC is equal to angle ACD. In side note or in justification, we can write here as alternate angles are equal. So in step 2 we can write here again AB parallel CD and BD is the transversal. BD is the transversal. AB parallel CD and BD is the transversal. So we can write here angle ABD means this angle and equal to angle BDC. So we can write here angle ABD is equal to angle BDC. So we can write here same justification as these two angles are alternate, as alternate angles are equal. Angles are equal. So we can write, now we can compare two triangles AOB and COD. In step 3, in triangle we can write here in triangle AOB and triangle COD. Now we can compare these two triangles here. Angle BAC is equal to angle ACD and angle ABD is equal to angle OBDC. So these two angles will be equal to this two angle, and AB is the adjacent side and CD is the adjacent side of angles. So we can say these two triangles are congruent according to the theorem of angle side angle theorem of congruency. Okay, dear students, so we can write here angle BAC. BAC we can write BAO also. BAC, or we can write BAO. BAO and BAC are same, so we can write anyone. BAO is equal to angle BAO equal to OCD, or we can write here ACD. ACD and OCD are same, so we can write here OCD. OCD. Angle, another one, we can write here step 1 from step 1. Now from step 2, if you want you can write here or angle BAO is equal to angle OCD, and here also if you want you can write or angle. Here ABD means ABO, you can write ABO is equal to angle. I have written here BDC means ODC, both are same, so we can write here angle ABO is equal to angle ODC. So these two angles are equal to these two angles, and we can say AB is equal to CD. How can we say? From theorem 2. From theorem 2. In theorem 2, just in the before, just I have shown that one in the previous theorem 2. Opposite sides of parallelogram are equal. For this, AB equal to CD, we can say. So we can say according to the angle side angle theorem of congruency, we can say triangle AOB is congruent to triangle COD. As these two triangles are congruent, AOB and COD are congruent, so we can say similar sides are equal. So we can say AO is equal to CO and BO is equal to DO. Therefore, we can say AO is equal to CO and BO is equal to DO. So, what we need to prove? AO is equal to CO and BO is equal to DO. So, our proof is done. So, we can write here. Dear students, theorem 3 also done. It means I have proved theorem 2 and theorem 3. Theorem 1 is given for your vacation homework. This is your homework number 22. Do your homework properly. Dear students, I hope you have understood both the solution of proof, and you can write in your language. Just you need to understand. Okay, dear students, keep practicing at home. Abide by your parents. Stay home. Stay safe. See you again. Till then, Assalamu alaikum.